computer. All right, this is going to be the second part of the lecture about other features in Cisco devices, lesson 3 in CIT 162. Let me get started by going back to the slides and picking up where we left off. So including just a quick little review of what we talked about. Oh, see, bad habit. I just opened up the slide like as if I was in a classroom. So let me hit share screen and hit the slides. There they are, my Chrome. All right, I'm gonna hit present. See now, let me see if I do this. That way you only see who's talking. I don't know if that will show up in the video or not. All right, I don't think so though. All right, so this is what we were talking about, big time functionality. We talked about sub interfaces and router on a stick, the concept that with this magical point at the end of an interface, all of a sudden magically you are, now the good thing about the pictures though is I won't be able to see the raised hands unless I have the pictures up. So anyway, I'm gonna just do talking, so the thumbnail, so that way you can fully see the slide. Anyway, so we have the dots at the end give you a logical interface that you can put in with your underneath. We'll do underneath since it's a sub interface. Under your physical interface, you get multiple logical interfaces. That's what the magic of this little point button right here. Let me bring up my pointer to show you the point. There you go. Again, and then if you do that though, before you give it an IP address, you have to establish what encapsulation you're going to be doing. So DHCP, we talked about how to configure DHCP, which essentially you set up the excluded addresses first. Those are the addresses that the DHCP server will not hand out. You name a pool. A lot of people just give their pools names, something that's descriptive. And then IP in pool is very popular as a kind of a half joke name. And then you establish what network it serves. This is what actually tells that pool, hey, you're going to be servicing, in this case, the 10.0.0 network, right? Because it's a /24. You can also put a /24 in the versions of iOS we have in our practices. And then default router, you give it the default router and you give the DNS. If you notice, within the pool is not when you exclude addresses, you exclude it in the global config, okay? And it is important to exclude addresses because otherwise, essentially Cisco being Cisco will hand out every single IP in this entire subnet if you tell it to, which would of course cause problems. It's classic. Cisco is, you know, one of the greatest examples of malicious compliance. So verification, again, I didn't put this in the practice. I kind of regret that. That'll be something I do down the road. I'd like to at least have you do it, but after you hand out IP addresses, it might be a good idea to Carlos, you want to just mute your mic?
No. Hey, Professor, sorry about that. My volume was down.
That's fine. Just mute your mic and then use the space bar to talk. There you go. Thank you.
Okay,
right,
got it.
So, no worries. So anyway, so again, you can do a show IP DHCP binding. That'll show you all the addresses you've currently handed out. These other ones are kind of, this is going to show you the config. This is going to show you just general statistics. The show IP DHCP binding is the one you use more than anything. All right, we talked, and then we ended last lecture talking about DHCP Relay, where essentially we can set up an interface. We go into an interface and we say, hey, listen for DHCP Discover broadcast. If you pick up a DHCP Discover broadcast, forward it off magically to this IP address. So this one DHCP server can cover all these subnets because this router has been told, at least on one of these interfaces, to send it off, although the addresses don't match because I made this drawing after the fact and slammed it in there. But the point, this should say IP address 10.162.1.101, right? And then in that case, whatever interface that's on here, it would then relay that that DHCP server. A relay would not be necessary here because this client, this DHCP client, is on the same interface as this DHCP server, right? So a simple broadcast will hit this DHCP server and it can do its job. It doesn't need a relay, right? If I do put a relay on there, ironically, I know someone's gonna ask that question, but what if you do? Well, if you do, what would happen essentially is the DHCP server would see 2 requests come in for the same MAC address, and the DHCP server is smart enough to say, well, it's the same MAC address, so I'm not going to hand out 2 different IPs to the same MAC address. And it would, assuming it was a well-written DHCP server, which would be most commercially available DHCP servers. If you're building your own home one, you're building one from scratch because you're a lunatic, you might get an error where all of a sudden this DHCP server will hand out 2 different IP addresses to the same MAC address. And then it's up to your client's operating system how it handles that situation, where send out a DHCP request broadcast and all of a sudden it gets 2 answers back. We're really in a theoretical land. So my point is you don't need to set up a DHCP relay on this interface because this client can hit this DHCP server without a relay, okay? So that's how we ended the last lecture, talking about relay. Now we get to talk about NAT. We get to do the complex stuff. All right, so first of all, we're going to start off with the 3 types of NAT, okay, in general speaking, okay? Hopefully this helps you understand, and this is stuff we've kind of already talked about, okay? So we have static NAT. That's a, static NAT is simply a one-to-one, okay? Whenever the router or whatever, it could be a switch, a layer 3 switch, whatever the Cisco device, iOS device, receives a packet that has this IP address, usually what we're going to call source IP address, we'll get into that, or local IP address, we're going to change it to a global IP address, or an outside address, okay, as it's usually referred to in the world of your home routers, inside, outside. Sometimes it's that. It's going to get confusing with terminology. We'll talk about terminology in a second. But static NAT, generally speaking, is a one-to-one. You can remember it by saying, static one-to-one. So this is where we're going to do a little bit of experimentation. I'm going to bring up the grid video, and I'm going to ask a question to everyone here. Why would we need a static NAT? Can anyone think of a situation where I sit down as a network engineer saying, I'm going to have to do a static NAT? So let me give you an exact scenario. If we have private addressing throughout our network, okay, and we have a server that we want people to get access to from the outside world, we would ironically need a static NAT, right? Because we would need a global IP for the people in the outside world to be able to get to our web server. Okay, now it's counterintuitive for a lot of home network folks because I'm going to hide the thumbnail video now. All right, so it's counterintuitive for a lot of home network folks because what you use is called port mapping. Okay, a lot of times, a lot of people have set up port mapping at home, especially if you got your own game servers or web server or whatever server you're trying to get to be able to connect to the outside world, right? Unfortunately, I'm using my hands a lot, which is not useful at all. Let me bring up my good friend, the Sketchpad. You get to see all my links here, which is fine. I don't care. There we go. Sketchpad. All right, so I'm gonna load up Sketchpad real quick. Again, erase wasn't working last time I checked. Certainly won't work there. Let me do a new drawing. We'll keep the blueprint background. I kind of like it, soft on the eyes. All right. So if I have again a server, I don't know why that's got a ice cube on the side. There it is. So this is a server of some type. I really don't care. Let's just make it a web server to make it easy. Port 80, right? It's doing port 80. And then, of course, we got switch in between here. I'm just going to kind of skip all this stuff, right? We got switches, we got a router, and everything else. The important thing, well, the router we're not going to skip, right? Because this is what's going to actually do the netting. All right, so be it. But I'm not going to be very specific on what type of router it is at the second, okay? Now I have my cloud, which is going to look really jagged in this program, but so be it. All right, so I have my cloud. What's going to happen out here, we have global IPs. We have public IPs. That's the terminology we learned in Networks 1, right? We're going to have, 24.1.1.1 and all these publicly routable IPs. If our company has a bunch of static IPs, let's give this thing an IP address of 10.1.1.1. I can't think of a more NAT address in the world. There you go, 10.1.1.1, right? So what needs to happen is at some point, if we want someone to go to this web page, port 80, from the cloud, right, we're going to need some kind of device to sit there and say, I have a couple strategies to do this, right? And this is where home routing versus a corporate situation. Corporate situation, if I'm setting this up with Cisco, I would say, aha, I need a static NAT. And what my static NAT will say, hey, if someone comes in and they're looking for, let's give it a public IP of 24, it's a small company, so it's got a Comcast connection, .100, we'll make smaller numbers so it's easier to write, 7.3, all right? So that's my public IP that I assigned to my web server, okay? Now, if I'm a Cisco company, or I got a Cisco operating system, iOS operating system here, what I can say is, hey, do a static NAT, and through the power of NAT, that's supposed to be an N, through the power of NAT, all right, what we're gonna do is translate this address. So when these people come in and say 24.100.7.3, what they really mean is 10.1.1.1, okay? Now we can get more granular with the commands. We can actually change ports. We can do all kinds of crazy things, which might be good for security. And that's why people like doing this, by the way. It adds complexity to the network, but I'm hiding whatever private address it is inside my network. Now people can still hit port 80. Anyway, what you tend to do at home is you don't have NAT, you have PAT, which we'll talk about in a little bit. On your home network, if you have PAT, what you're doing is you're sharing everything in the inside part of your network is sharing one address. You don't have multiple addresses to assign and say, this address is going to be a static NAT. You're stuck with it, right? Here at Stick, for example, the entire 134.241.100 subnet, the whole 24-bit, 24-bit CIDR mask, 255, 134, 241, 100 network is all public, all IPs for the sole purpose of NAT translations. So if someone at Stick wanted to bring up another server, I could just sit there and say, okay, you're gonna have your public IPs gonna be 134, 241 dot. We try to make something sexy like 33, 42, something, but we'd say, okay, that's your IP. Now send that off. We'll send that off to our ISP, which has their own DNS server. That DNS server will then propagate to the world that, hey, if you want to go to http.rodneytheramspersonalblog.com or .edu, whatever, whatever the URL is, translate that to 134.241.100.42, since Rodney the Rams, the meaning of life, the universe, and everything. Okay. Point is, that's what we're able to do with a one-to-one NAT. What you're doing at home is you're doing PAT, and PAT you have only one IP to do. So what you're doing with these small kind of SOHO, small office, home office, that's what SOHO stands for, routers, is you're going to come in and say, well, listen, yeah, we're all using 24.100.7.3. We'll use that we call it port mapping, right? So we're not doing that here. Matter of fact, what I decided to do is I'm going to erase things. So I click on this, and I think what I can do is just highlight. I don't want to get rid of the 24. Oh, this is terrible. Oh, I can just. All right, there we go. So we're not doing NAT. We're going to do PAT and port mapping. I'm not spinning it. All right, there we go. I'm going to do port mapping. Okay, with port mapping, what all port mapping does, a lot of you've set this up, so I'm kind of preaching to the choir. But for the folks that haven't, what port mapping does is it says, okay, cool, we're all using 24.100.7.3, but if someone from the outside world wants to hit 24.100.7.3 port 80, send it over to this IP address of 10.1.1.1. Okay, that's using PAT and port mapping. What we're talking about here, and let me go back to my, did I change that? That's terrible. That's horrible. I'm going to, apparently I got rid of my drawing. I'll bring my drive up and bring or my slides. Must have moved over. All right, go back to presentation.
Professor.
Yes.
So is PAT kind of like the opposite of NAT?
It's not the opposite. We're going to talk about PAT in a little bit. I just want to give people an idea. So we are going to talk about PAT, or in the world of Cisco, we call it, and everyone sees the slide right now, right?
Yep.
All right, making sure I got understanding. So PAT, we're going to talk, in the world of Cisco, we call it overloading. You'll see it's a special key term, but we call PAT overloading. And again, a lot of us say we do NAT at home, but we're actually all doing PAT. NAT is actually a one-to-one static. And there's two types of NAT. There's static NAT, where we do it a one-to-one. We say this IP address gets translated to this IP address, right? That's all we're doing here is we're scrubbing. And in the world of Cisco, in most normal NAT, simple NAT, you're only changing the source or perhaps the destination. One of those addresses. In the world of Cisco, we can change them both. But so we're going to change the layer 3 header, okay? And we're either going to change we could either change the source or the destination to a different, or both actually, to a different IP address, okay? We can actually change it to, in the world of Cisco too, if you're really good with NAT commands. I alluded to this earlier, and if it confuses you, just forget it. I never said it, but you can actually change the port numbers too. So just fun fact. You can fully manipulate a packet. But anyway, using NAT. But NAT allows you to change either the source or destination. Usually it's going to be, if it's outgoing traffic, it's usually going to be the source. If it's incoming traffic, it's usually going to be the destination. You only change one of them on the simple world. But with static NAT, you're doing a one-to-one translation. I see you raise your hand, Adam. Go ahead.
I just wanted to chime in about PAT, and the way that I understand it is for Carlos, like at your home network, you have all these different devices that basically have the same network ID, obviously different host numbers, but they're all going out to the internet via one WAN IP. So all of those different inside addresses have to translate to that one WAN IP. Now you wouldn't be able to have, like we have, how many devices are running in your house right now? Like I have 2 laptops, a cell phone, maybe another laptop and something else, a TV upstairs that all have IP addresses. You can't get that many public IP addresses because that's the issue with IPv4. That's why there is NAT and PAT basically. So what it'll do is it'll give all of those devices one WAN IP, so one external facing IP, but different source port numbers. And I think, correct me if I'm wrong, Professor Alves, that's where the port address translation name comes in. So when your traffic is going out there, the source port is going to be different, but the IP is going to be the same. And therefore you can have multiple devices on an inside network translated to one external facing IP.
Yeah, that's exactly it. The reason why we call it port address translation, as Adam alluded to, was what we're going to do is we're going to keep a giant ledger. Now the fun thing is you're going to be able to see this. You'll see this in the practice actually, because when you set up PAT in Cisco, which you'll be doing in the practice, you can do show NAT translations and it will show you the ledger. What happens is a device set up to do PAT keeps a big ledger and says, okay, 10.1.1.1 went out to talk to Google, right? Which is whatever Google IP is, 81.50. Whatever the IP address for Google is. I can expect at port 80 or 443, I can expect return traffic going with a source of 443 using the same dynamic port. Remember, there's a source port and a destination port. When you send a request out to a web page, a secure web page, we'll use 443. If I send a request out to a secure web page at 443, that the source port is going to be dynamically assigned. It's going to be in the 50,000, chances are 48,000 to, I'm trying to remember the exact numbers, 64,000. It's going to be randomly assigned out of those numbers, right, and kept local on your local machine. And then the destination is going to be 443. Based off that information, and the return is going to be, the destination is going to be 443, and the source is going to be a dynamic port, the same dynamic port. So based off that information, the router go, aha, this is, or a firewall, right? This is kind of how firewalls work too. But the router or the firewall can say, aha, this is all part of the same session. The magic term is going to be session, okay? So it's all part of the same session, all right? And because it's all part of the same session, then it can keep track of it and say, oh, this traffic is meant to go, even though it says it's my IP address, my router's IP address or firewall or whatever, aha, even though it's sent to that IP address, you actually want to talk to 10.1.1.1 because they went out and they talked to Google, okay? That's what PAT is, which is fine. We kind of went over right to PAT. That's perfectly fine. Now, the weird stepchild to both of these is called dynamic NAT. That should be a NAT at the end of it. Matter of fact, I don't know what you're talking about. I don't even care if this is being recorded. It always said NAT. Believe me, you can believe me, it always said NAT. All right, there you go. Dynamic NAT. Okay. Subnet to a pool. I'm not in love with that definition. I got it from somewhere. Many to many is the better way I would put it. Okay. We have many IPs. Matter of fact, so much I'm going to like it. It always said many to many. I don't know what you're talking about. Even though I'm recording this. You're a liar. You're being dishonest and mean if you tell me it said anything else. Many to many. All right, there we go. Many to many. So what we're going to do, unlike static, dynamic, you're going to have many IPs, possibly translating to many IPs. Again, there's wiggle room here. We can actually have we can have one IP using many IPs. You can have, technically, you can set up PAT as well and have, so what's the difference between dynamic NAT where it has one to many or many to one is a little, it's kind of one of the same. But dynamic NAT, you can actually set it up where you have round robin. You say, hey, these 4 IP addresses have been assigned these 2 global IP addresses. Now, why would you do that? Well, it's weird. It's not going to be useful for static because you're going to kind of do a round robin, all right? And if it does a round robin, then there's no way for me to predict what IP is going to get assigned to what IP. It's usually done for efficiency purposes or security purposes. I had some networks under my control where they were going to a secure bank, and the bank just had it hard-coded that it wouldn't let multiple IPs into the account. And I had that particular network only had like 10 workstations. So I just set up a many-to-many. I had 10 workstations, round robin to 10 different IPs. It wasn't a matter of efficiency or security on the client's end. It was security of the bank. So the bank was like, if we don't want anyone piggybacking on an IP connection, so only one session per IP. So when I first set it up, it was set up as PAT just to keep things simple. And then I went back and did a many-to-many. It's kind of an oddball thing. It's the weirdest one of the bunch. Static makes perfect sense. If you have a server network that has private IP addresses, but you want people from the outside world to get to those IP addresses, you're going to have to do a static NAT, right? You're going to have to map it directly to a global IP because you're going to need people to, you can't tell people, hey, go visit my website, and you say, oh, what's its URL? Well, sometimes the URL is this because it points to this IP. Sometimes the URL is this because it points to this IP. Sometimes the URL is this and points to this IP. And this is where someone can say, but there's a feature called dynamic DNS. Yes, you can do dynamic DNS and work around it. But in a perfect world, I sit there and say, hey, hit my website, hit this one URL that translates to this one IP address, which will get translated on my router firewall to a server. That would be static IP, one-to-one. Dynamic NAT is when you have many-to-many. We can have many IPs, a pool of IPs. We're going to use the term pool, just like we do with Dhcp pool. We're going to have a pool of IPs. Translate to a pool of IPs. We're going to set up that pool of IPs. And then we're going to have PAT, and I'll get to you in a sec, John. Then we're going to have PAT, which we call overloading IT. With one way to remember it is many to one, like we were just talking about. In fact, so much so that this slide always said many to one, although I'll have to shrink down the whole text and everything else. Many to one is the way I like to refer to it. Many to one. All right, and I'll do Control A. I'll shrink this down, and we hit present. Never, it always said many to one. I don't know what you're talking about. So there you go. Many to one. It's on the bottom. I can't see because of this. You guys probably see this thing as well, right? Yeah. It'll go away. All right. So many to one. There you go. John, you had a question?
Yes, sir. So do we utilize a static NAT if we have a web server and a DMZ?
Well, if you have a DMZ, you have a firewall. So, but your firewall will do static NAT if it's a Cisco firewall, if it's iOS. In this particular scenario, we're doing routers and switches. So we're not going to get too much involved with firewalls. We're kind of doing that in 251. We're doing some firewall configurations. So you would do a static NAT if you're doing, but if you had a web server, if we're setting up a router, let's just do this, keeping in the confines of this course. If I had a router and I had a network called my server net, right? and it was all private IPs, and then we had a WAN connection. We're going to see this in our practice a little bit. We're going to set up a PAT, but if I had a web server and I wanted someone on the other side of that the public side to get to my web server, it needs a global, or we're going to use the term global in the world of Cisco. We'll get to that in a second. A global or a public IP, right? Because if I try to sit there at home and type 10.1.1.1, it will look at my local network and say, I don't have a 10.1.1.1. It won't send it to the internet. Remember, the private addresses are non-routable. So this would be the only way people get to that web server. Does that answer your question, John?
Yes, sir.
All right, thank you very much. Any other questions? I'm gonna muddy the water some more, and then we're gonna talk about it. I actually have a diagram, so I'll stop doing those ugly drawings. And then we'll actually look at the configuration, how to configure it, every single type, okay? So now, Cisco does NAT in a very complicated way. This is the Cisco way, okay? Again, for engineers by engineers. The reason why they do this is because with complexity comes power. It's gonna be one of your, again, one of our key rules of IT is keep it simple, stupid. But ironically, with complexity comes power, right? The more complex something, like look at C versus Python. Python's great. I love Python, but because it's a simpler language, you don't have to define variables and all this. You don't have to define variables as much as in C. But that complexity of C gives you more power. And that's why, like for example, Windows is written in C, right? Because there's more power. It'd be harder and less efficient to write Windows in Python. It'd be really difficult, right? And be a slower version of Windows, if that's possible. No, all right, no, I don't mean to bad. I'm using Windows right now. My Linux laptop hasn't been booted up in a day now. I feel sorry for it sitting over there. Anyway, so long story short, with complexity comes power. Okay, so Cisco does this in a very complex way, but it's going to give us power. Let me get my pointer. All right, so you can see it better. All right, so we're gonna have two things. All right, and those things are gonna have two polarities. Okay, inside, outside, and local, global. All right, what do we mean by that? Well, inside, outside is the network source and destination. All right, I don't know if everyone at home can see that. Hopefully that made that smaller so you can see it. But inside, outside, the network source and destination. The inside is the source, outside is the destination. That's an oversimplification, to be a little bit honest, but the inside network is what you control. The outside network is what you don't control. All right, so case in point, in our room back in 315, which we can all feel sad that we're not in there right now, but back in our room in 315, I have inside that lab, I have a router, right? That's set up. That's set up in the classroom. That's plugged into the stick network. Inside that classroom, everything beyond that router and beyond is my inside network. I control that. Sticks network, which I don't control. They took away my admin privileges years ago. Is the outside network. Okay, that includes also the internet. But so it's a philosophical thing. Inside is stuff you control. Outside you don't control. To boil it down into a small little bullet point. Inside is the source, outside is the destination, okay? Then we're gonna have global, local. And I was trying to sprinkle that in. I was trying to seed that in when we were talking about the different types of NAT, right? Global is gonna be the public IP. Well, that's not 100% true. Local is gonna be the IP used locally. That's often the private address, okay? Back in that scenario we talked about, in the scenario we're gonna look at here, okay? It's nice. This is essentially the same drawing I had, that ugly drawing I had in, and actually this is a bad, well, we'll work our way through it. But this is a better version of what I had on the sketchpad there, okay? We have a workstation which actually has a privade address of 192.168.1.200. A router, here's its interface, is simple /24 network. We got a little bit complex here, and it's got this has a public IP at the cloud level. Okay, and we're just going off to a stick. All right, we're not worrying about this. This is Stick's old web page, old website IP. The IP's changed now. We've outsourced it. But anyway, so if I'm sitting at my home router, let's just say, right? We're gonna just do a simple, we're gonna do a PAT translation here, okay? And what we're gonna do, and the primary thing I wanna get in is inside, outside, and local, all right? So if I'm running NAT on this router, which I am, because it has a public IP and I need to get to this public IP, but I have a private address and I gotta go through the internet, the cloud, right? I'm gonna have to do NAT, right? What type of NAT, all that good stuff, we're not gonna worry about that right now. What I wanna talk about is inside and outside, okay? So the inside's here, because this is me, okay? And we're not saying we're stick here. We're saying we're this thing, okay? So for us, this is inside. This is gonna be my inside network, okay? It's 192.168.1.0. That's gonna be my inside network, okay? This is gonna be my outside, okay? This interface out to the cloud, this is the outside. The whole rest of the universe is the outside, okay? That's the important thing to understand, all right? We're gonna see this in the configuration, because when I tell the router, I have to tell the router, hey, this is inside, hey, this is outside, okay? Real quick, let me bring up we'll bring this back to our practice we're gonna have. I'm gonna share out the practice thing. It's gonna be less than, oh, I have to stop this share or new share, aha. And one day I'll get decent at this and then it'll be time to stop. All right, so back on our practice, what we're gonna do is we're gonna tell the router, hey, this is inside, because we're in control of it. Hey, this is inside, because we're in control of it. And this one here going out to the internets is gonna be the outside for our NAT translation, okay, to get it up and running. All right, that's what we're gonna do and to get that to work, all right? And so you'll see that in the practice, how that kind of works a little bit, all right? So again, inside's what you control. It's the source, and make sure you guys see the slides, right? I'm just making sure I didn't screw anything up. You should be back to slides, I think. Let me get pictures up. Yes, okay. Adam's, all right. Adam's nodding his head. All right, so we have the slides right here. So again, inside, outside. All right, we'll see this in the commands in a little bit, okay? And now we have to worry about local. Here's a local IP, which in this example is a straightforward example. The local IP is a private IP, but part of whatever I'm doing, NAT, probably PAT because it's a home network or whatever I'm doing, NAT, dynamic NAT, static NAT, or PAT, whatever I'm doing, I'm going to translate this local IP of 192.168.1.200 over to a global IP of 24.156.23.82. All right, just so we just want to get the terminology set because Cisco is going to use that right here, NAT inside, right? So we're going to use that terminology when we use the commands. Okay, so when we do run the commands. All right, let me just go through the commands and then I'll open it up to questions because I'm hoping the commands might actually help you see this, right? Because right now it seems like this complex, very philosophical thing. But once you actually sit down and start typing it out, you're like, oh, okay. And believe me, I haven't set up a NAT connection in like 6 months or whatever, and I sit down to do it, I have to think it out. I'm like, oh, what the? But it's when you actually type it in, you're like, oh yeah, it's simple. It's a complex concept that you can eventually boil down to the simple concept of the command, the actual execution. All right. So if I'm doing a static NAT, it's nice and simple. In global config, I say, hey, we're going to do something in IP. It's going to be NAT, right? So those are the first two command keywords. We're going to say, okay, on the inside, all right, source, all right. When I say inside source, I'm saying this is what the IP is going to be, right? Static. So we're only going to do this one IP, and we're going to do 10.1.1.1 is going to get translated. For whatever reason, I picked this as the global IP address. We're going to translate it to 170.46.2.2. Now the router's smart enough to realize, and there's going to be more parts of these commands because what we need to do is go interface by interface and establish what the inside and what the outside is, right? So in this example, it'd be interface gigabit 00 and interface gigabit 01, right? So what would happen with that IP static NAT translation, anything coming from Internet Gigabit 001 that's got the IP address of 10.1.1.1 would get, and if it was going to the outside world, to the outside interface, it would get translated to 170.46.2.12. If it was going anywhere else, if it was going to some, say there was another third interface of interface Gigabit 03, it would not get translated, okay? So there's three parts to setting up NAT. You tell the device what we're doing, right? This is the game plan, and then you have to tell it what the inside and what the outside is, at the very least. Ideally, what you do is you establish all the interfaces that are on the inside, but at the very least, you have to give them one inside and one outside, and then NAT will start working, okay? What I like to do when I'm setting up NAT is have a device pinging right next to it and have a continuous ping, fail, 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 fail. And then all of a sudden, just checking the time, and all of a sudden, once NAT starts working, abracadabra, you got internet. I can ping 1.1.1.1 or 4.2.2.2, whatever floats my boat. All right, so that's the
Professor,
simplest.
excuse me.
Yep, Carlos.
Could you briefly go back just a little bit to where you were talking about setting up the gigabit Ethernet connection?
Right here. So in this case, the gigabit Ethernet's already been configured. It already has IP addresses. It's already routing. But what we're doing is we're setting up NAT. Okay, so we just have to go interface by interface. And let me actually show you on our practice. So like, for example, here, I have a router in the middle. Let me bring up the console. By the way, this is PuTTY, even though it has the same color scheme. What I would do is I'm in config mode. I'm going to do IP NAT. Oh, I haven't set up an access list yet. I would say, well, let's do a static. IP NAT source static. Do I want static now? Yeah, I want static now. And then I'm going to give the we'll give it a local IP of 172.22.22.60, whatever. We'll give it 60. And now all I got to do is tell it what I want for a global IP address, right? So in this case, my global, confusingly, because this is a simulator, is also going to be
I can't see your PuTTY.
What's that?
I can't see what you're doing.
Oh, thank you. Sorry. Yeah, I have to share the PuTTY. I completely forgot. Share. There you go. Now you got the PuTTY. Sorry about that. Thank you. All right, let's go back. Right. Well, all I did was, I'll do what I did. I did IP NAT. I knew I was going to do NAT. And I said, oh, wait, is this where I want to do source? I think it's where I do source. I tabbed it out. And I said, I want to do static now, right? So I had a question mark. And I said, that's right. Yeah, this is why I do static, right? So now we're going to do static. Now that we told it static, it's nice and simple. It says, okay, what do you want to do? Again, you can do crazy stuff like change port numbers and protocols. We're not going to go that crazy right here. But I'm just letting you know. So right here, it says you can put the source local IP address. Okay, I'll just make one up, 172.22.22. I'll put it on this VLAN, actually, VLAN 1.60. So we're going to translate something from this subnet over to and back from the public IP of 192.168. Will let me use the interface? I think it will. Yeah, okay. So I'm going to use, okay, and this is, by the way, where the simulator would crash in the past. If you didn't give it a memory upgrade, that's exactly where it would crash. But anyway, so it says, okay, cool, I could do static. But it wouldn't work right now until I go into the interfaces. I'm going to drag, you're getting the same share, but I'm going to drag it over so I can see the interfaces. I have to tell it I want interface Ethernet 01, right? So I'm going to go to interface Ethernet 01, which is actually, I have sub interfaces, so I'm going to have to do .1. Actually, it's what's servicing VLAN 1. Just so happens that's the IP I picked, and I'm going to have to do IP NAT inside. Okay, and that's going to tell that interface, aha, I'm an inside, right? So now I know my inside. I know my local, right? My local is going to be 172. I know my local IP. I know my inside interface. What I haven't told it, what is going to be the outside interface. So I have to go to interface 0, Ethernet 00, and I just say, hey, you're going to be IP NAT outside. Okay, so now, and I'm going to go back and share out the drawing. With those commands I just typed in, What I just told it was, hey, this sub interface right here, .1, is going to be inside. This interface here, Ethernet 00, is going to be outside, and use the IPNAT command static. So anything from, if I had something out here with an IP of 172.22.22.60 that wanted to go out to the internet, when it goes out this interface, it will get translated to, confusingly, sorry, it's a private IP. And that's why I said, even if it's static, you can statically change to a private IP. But it's gonna statically change it to 192.168.122.2, which just so happens to be the IP of this interface right here. Now, the cool thing about that too is if I had a web server over there, that was a web server 172.22.22.60. If someone from the internet or from this NATed address, if I had another workstation connected to this, and I came back and I pinged that IP address and had routing set up to ping that IP address of 192.168.122.2, it would actually, the router would do the reverse of that too. It would say, okay, this is coming from the outside. You want to hit this this IP of 192.168.122.2. Well, guess what? I'm going to do a static translation, and it's going to get sent over to that back over to that server. All right. That's the beauty of static. It's only one or two commands, and then you have this nice static communication going back and forth. All right. We're not going to do that in our lab. We're going to do the much more commonly used PAT, which we'll talk about in a sec. The next one we want to talk about is dynamic. It's really it can get complicated. Just know that you're going to set up a pool of IPs. So instead of saying IPNAT inside, what I'm going to say is IPNAT, hey, the pool, look for this pool of IPs, okay? And then we're going to go globals. So whatever's in this pool of IPs, I set up a pool, I apparently called pool here, and then we're going to change it to these globals of 170 to 168.2.3, all the way to 172. We give it a range of IPs, right? So what we did, we said, listen, there's a pool of IPs, right? Oh, and I got a, yeah, IPNet and source inside pools global. All right. Okay, I'm sorry. Let me get, I got my commands messed up here. This is going to say IPNAT set up a pool called globals, all right? And this is going to be, this is a pool of IPs from 170.168.2.3 all the way to 170.2.254, okay? Then I have to do an access list. We'll talk about this because we're going to have to do it in our practice. Wildcard, welcome to subnet mask. This is a subnet mask when you do an access list. We're going to talk about access lists next lesson. But just know that and I mentioned this before in class, but for some people, this is the first time they're hearing it. This is what a subnet mask looks like when you do an access list. Why? Because it's Cisco, and sometimes they just like to make your life difficult. We just flip the access list. So it's easy when it's a classful or a subnet mask that ends. In this case, we have a /24. So instead of 255, you have a 0. Instead of a 0, you have a 255. So the network is 10.1.1.0. That's the network, okay? We'll talk about that next class. Just know we're going to have, I tell you what to type in the practice, although the extra credit, you have to do the math. The easy way to figure out really quick in your head, let's jump over. The quick way to remember to do the calculation in your head, as far as, we're going to do blank. Don't say. The calculation is like, say if I got 0.0.0. I gotta do math in my head now. Let's just do 3 plus. All right, we'll do 7. So this would be the wildcard mask. Okay. The quick, easy way to do this is you just subtract that from 255.255. .255, like good old fashioned subtraction, .255, and it'll give you the proper subnet mask, okay? So if I subtract 0 from 255, I end up at 255. Oop, 255. .255, .255, and this is where it's complicated, is we're gonna take 255, we're gonna subtract 7, so the real subnet mask would be 248, okay? What's going on is Cisco, just anything that's a 0 is anything in a traditional subnet mask, anything that's a 1 is now a 0. and anything that wasn't one is anything that wasn't one was a 0. Anything that's a 0 is now a 1, right? So instead of being like for this last octet here, where in a classic subnet mask, that would be 1 1 1 1 1. No, just 5 1s. It'd be 5 1s. In this case here, it's 0 0 0 0 1 1 1. Okay, 5 zeros and then 3 1s. All right, wildcard. Don't ask me why Cisco did it that way. I think someone in Cisco just decided that's how way subnet masks should always work, and it became ironically the tradition that the access list will be done that way forever. So now it's a rite of passage that everyone has fun with wildcard subnet masks. So that's what's called wildcard subnet masks. But an access list is what you're doing. So what this access list does is it says, hey, I have an access list. It's going to include everything, the entire network 10.1.1.0, okay? And then with the /24, okay? Now I do the IP actual real NAT command. This just sets up the pool. That's where I got confused before, and I apologize about that. This is actually the NAT command. I'm going to say IP NAT inside source list, talking about an access list, 1, the one I established, okay? Pool globals, all right? So what I'm doing here is I'm saying, hey, IP NAT, we're going to your inside network is this list right here. So anything that starts with 10.1.1 is yours. It's going to get NAT translated over to this pool that I've created called globals, which goes from 170.168.2.3 all the way to 2.254. So that's almost a whole 24-bit mask, but whatever. For whatever reason, I set it up just showing you it doesn't have to be /24. The point is I've set up this range of IP addresses. Now what's going to happen is, and then we do it inside and outside, right? We'd go to an IP address, or we go to an interface, we say this is your inside. We go to an address, we say this is the outside. It has to be able to handle these IPs in order for that to work. Any traffic that goes into that inside interface that matches this source of 10.1.1.1 would get translated. Now you have different ways to translate it. We're not going to go into the various ways, but there's round robin, there's load balance. There's 3 or 4 different, I think 3 actually. They got rid of one way. So there's 3 ways to translate into these globals. By default, it's going to round robin. So the first IP it hits will get 2.3. I don't know if it goes sequentially or up or down, but let's just say it goes sequentially up, right? The first one get 2.3, the next one get 2.4, the next one get 2.5, and cycle through, all right? And it times out after a minute or 2, and then 2.3 gets back in the pool, okay? That's what it would do. That's a dynamic NAT situation. Again, it's not common to have dynamic NAT, okay? What is common is PAT, IP overload, okay? And the reason why we call it IP overload is because, why am I setting up a pool? Oh, well, I set up a pool on overload. That was overcomplication. In your practice, we're just going to point it to the interface and just say, just like you do at your home router, you're going to say, hey, guess what? Use that interface, okay? So we're going to do, real quick, you set up your access list. You're still going to need an access list. So in this case, it's the same access list. Okay, we won't worry about the pool so much. We called it global net for whatever reason. Anyway, so we set up our access list. We're going to say IP NAT inside, again, just inside source list. This is your list of IPs. Anything anything that's set up to be an inside interface for NAT, right, that has an IP address of 10.1.1.0, right, you're going to translate over, in this case, to this pool called global net, and we put the command overload. Overload says, hey, you're doing port address translation, which makes it different the way it functions. It's not going to do round robin like the dynamic NAT. Most of the time, what you do is you give it a single IP address, or you could actually give it an interface. The way that would look, and I'll do that real quick in our lab. Is this the one I had? Yeah, this is the one I had. So I did IP NAT inside, outside. Let me get rid of that NAT command. So I'm going to go back into global. I'm going to copy. I got the extra. Oh, actually, I'm in PuTTY. I'm not in Linux. I'm going to go config T. I think I got it. Let's see. I got stop remembering I'm not in Linux. I'm in PuTTY. I can right click and it paste. Yay, PuTTY. All right, IP NAT. So I'm going to get rid of that previous IP NAT. If I want to do overload instead, I would say IP NAT Oh, I have to get an access list. Shoot. All right, so real quick, I'm gonna do access list. We're gonna pick on the same one. So I'm gonna do access list. I'm just giving it a number. We're gonna call it, yeah, 162 is a standard access list. Again, we'll talk about this in access list. Whoops, I got the command wrong. Oh, that's right, standard. No, see, I was extended. That's what my problem was. We'll just do 62. All right, access list 62, and I'm gonna do a permit. 172.22.22.0. Actually, it's not .0. Shoot. That's right. We'll pretend it's .0. Well, it is .0, but it's not. It's going to be 0.0.0. The first 3 octets are what we're going to match, and actually, we're only matching the first 2 octets. So everything else is on. So I need to subtract 192 from 255 real quick in everyone's heads. Is going to be 50, 192, 255. Why am I doing it? 62? Oh, wait, 192. No, it'd be 63. It's always going to end an odd number because the 1 bit's going to be on. So there you go. So there you go. I put that in. I'm going to do a quick. So I've established my access list. Now I got it back into global mode. I'm going to do IP NAT. Time check. We're running out of time. IP NAT. We're in config mode. Okay, yeah. So inside source list. I named it list number 62, if I remember correctly. And I'm gonna I could do right to the interface. I'm gonna just say, hey, guess what? Use interface 00's IP address, or I can give the IP address. Well, I can in this case, this particular version of iOS, you can only do interface. So I do interface Ethernet 0001, and I'll work. Oh, I forgot to do the overload, the most important part. Overload. That way it knows it's doing pat. And there you go. If I do show, run, you'll see the command in the wild, right? So now I have my, that was above the interfaces, maybe I'm wrong. So I have my IP outside, 00 is the outside, 11 is gonna be inside, right? And then here's my actual NAT command. It's gonna be up here, IP NAT inside source, list 62, use the IP address of interface 00, which is at 192.168.122.2. So anything that comes in over this network, .1, 172.22.22.0, this is .0, it's a 224 mask normally, would get translated over to that IP address, okay? So that's NAT. I know it's confusing. Oh, by the way, and also, unfortunately, I don't have any workstations running at the moment, but one way you can verify it is if you, come on, go away, you silly thing. Hopefully, I'm doing the right share. Yeah, I'm sharing it. Okay, good. So, all right, come on, just go away. Is you type show IP NAT translations, and that will translate. That'll show you all your current NAT translations. If I had workstations up and running, it would show you them working. All right, I think we're gonna have to do a third lecture. Sorry, everybody. In the practice, you're gonna have to do this next, which is just setting up. First, you're gonna do the sub interfaces, and then I'm gonna have you do layer 3 routing. You're gonna end actually in PAT. This last part, NTP, is dirt simple, right? It's really simple. So next lecture, we'll talk about layer 3 switch routing. It's kind of simple actually, but it's conceptual and it's important to get it out there and spend our time on it. So what I would recommend in our practice, if you want to start moving on the practice, is get the first part done where you're setting up sub interfaces, and you can kind of dump out after that. All right. So we'll pick this up next class. I'm going to stop the recording. Well, any questions before I stop the recording? We got about 1 minute left. All right, so I'm gonna stop the recording and then, which I can do with one of these buttons. No, that's the new share. It's the stop share. Okay, so you get my video back. And well, I can end the meeting, or I can, Oh, here it is, the stop button. All right, stopping the recording after all that complexity and awkwardness. Okay, goodbye, everybody. There'll be a part 3 where we talk about layer 3 switch layer 3 switching or layer 3 routing on a switch. Okay.